Space is not silent. It only speaks in a temperature too slow for our ears to hear. Between the freezing breath of 270 degrees Celsius and the gentle burn of 120 degrees, the universe remembers, evolves, and dreams. In this narrow band of heat and frost, the cosmos writes its biography, atom by atom, particle by particle, moment by moment. When we look into the darkness, we imagine emptiness. But the void is not empty. It is layered with gradients, with invisible tides of warmth and cold that stretch across light years. The universe does not stand still. It cools, it warms, it oscillates. Like a lung inhaling starlight, heat expands, cold preserves, and life lives between the two. At the edge of interstellar space, where sunlight dies into thinness, temperatures fall toward absolute zero. Molecules drift like ghosts. Reaction slows until time itself feels breathless. Objects there do not decay, they wait. A grain of ice can survive billions of years untouched, unchanged, unaged. The cold is memory, a perfect archive, a library of what once was and what may be again. But turn toward a star, move even slightly closer, and the universe answers with fire. Dust warms. Gas begins to stir. Frozen molecules loosen like fingers after long winter. Chemistry wakes, stretches, recombines. Heat is not destruction. It is ignition. 120 degrees is not a limit here. It is an invitation. Somewhere between the burning roar of stellar cores and the silent stillness of the void, planets form. Oceans appear, atmospheres learn to breathe. Water becomes river, vapor, storm, then cell, then thought. None of it possible in perfect cold, none of it survivable in perfect heat. Life is the tension between extremes. A planet survives because it does not collapse into starfire or crumble into frozen stone. It lives in the moving middle, warmed by distant suns, cooled by infinite night. Temperature is not background. It is the architect. It shapes worlds like clay, carving continents, stirring winds, forging oceans that carry memory from one age to the next. The universe is thermal music, and we are a few notes in its slow symphony. To understand what happens at 200 centimeter or 120 degrees is to understand why we exist at all, why atoms cling, why molecules dance, why consciousness can flicker against the darkness for even a moment. We are not separate from temperature. We are born from it. Every star is fire that remembers ice. Every comet is ice that once dreamed of fire. And somewhere between them, we opened our eyes. In this journey, we will walk between frost and flame. We will see what a molecule becomes when cold slows it close to silence, and what matter transforms into when heat shakes it beyond recognition. We will follow temperature as it writes planets, destroys them, and resurrects them again. This is not a story of heat or cold, but of the narrow miracle between. Close your eyes. Breathe slowly. Feel the warmth of your skin, the coolness of the space around you. You are already the balance. Now we descend into the cosmos, 1 degree at a time. Space is a gradient, not a temperature. There is no single number that defines it. Only transitions, slow shifts, invisible tides of energy that shape matter like wind shapes dunes. If you could drift through the void without dying, you would feel no heat and no cold, because temperature needs matter to exist. It is not a property of emptiness, but of interaction. Where there is nothing to touch, there is nothing to burn or freeze. And yet, space is filled with temperature. We only feel it when something is there to feel. A grain of dust near a star glows warm, absorbing photons like ancient skin taking in sunlight. Small as pollen, fragile as ash, yet at 120 degrees it becomes restless, molecules loosening, atoms vibrating a little faster than before. a tiny piece of matter learning movement. To drift farther is to fall into twilight. Light thins, warmth fades. The dust cools again, slowly, gently, until its vibrations grow quiet. At 200 deg it stops reacting. At 255 deg its chemistry becomes memory. At 270 deg it reaches near-time suspension. Cold is stasis. Warmth is possibility. And possibility is where stories form. Imagine an asteroid wandering between planets, frozen exterior, warmer heart. On its surface, 240 degrees, brittle like sugar glass. Inside, perhaps 120 degrees, enough for organic molecules to shuffle, rearrange, evolve. A small world split into two temperatures, two histories, one preserved, one changing. Life, if it ever lived there, would move in seasons thousands of years long. At 126, close to a star, water no longer behaves like water. It does not simmer, it escapes. In the vacuum it boils instantly, not because of heat, but because there is nothing to hold it still. Ice sublimates without melting. Liquid cannot exist. Heat becomes motion. Cold becomes storage. A comet is a freezer that travels through fire every few millennia. As it swings inward toward the sun, its shell warms, but its core remembers. It exhales long tails of vapor, history released as mist. Every comet is a diary written half in flame, half in frost. We think of temperature as comfort or danger. The universe thinks of it as architecture. Heat sculpts, cold preserves. Together they build planets. Take a world young and molten, crust glowing like ember, seas of magma flowing slow as blood. Too hot for oceans, too bright for atmosphere. But as it cools, just enough, volcanoes breathe water vapor, rocks fracture into minerals, basins form, rain begins, rivers carve, oceans settle, chemistry awakens. Between boiling and frozen, continents rise. Between 207 values and 120, elemental bonds loosen or tighten just enough for molecules to build. Carbon links with hydrogen, oxygen finds structure, nitrogen learns flexibility. This is not chance, it is temperature writing instruction. The universe is not chaotic, it is precise. To form a planet, heat must expand and cold must solidify. To form oceans, ice must melt but not vanish. To form life, temperature must circle, day, night, season, heartbeat. Everything alive is a loop of thermal change. Your own body is proof, 37 degrees Celsius of balance. A fever at 41 degrees Celsius threatens memory. A drop to 20 degrees Celsius ends thought. You are a star diluted, cooled, stabilized into awareness. You are heat slowed into thinking. And like the universe, you exist only because temperature has not yet settled. The cosmos is still awake because there is difference. Because stars still burn. Because ice still keeps memory. Because between 279 and 120s, life is still possible. Part 1 closes with a simple truth. Temperature is not environment. Temperature is evolution. Next, we step deeper into stars. Stars are heat in its most articulate form. They are not flames, but pressure held still by gravity. A war of expansion and collapse that ends in radiance. A star exists because temperature refuses to lose. Its core burns millions of degrees, its surface is cooler, but still violent. And yet, from such chaos, balance emerges. Heat in a star is not random. It is structured fire. Inside the core, hydrogen atoms collide with such force that their boundaries dissolve. 4 protons become helium, mass becomes energy. Light becomes movement. Each fusion is a sentence written in temperature, a phrase of creation. The star does not simply shine, it speaks. If we stood close enough to a stellar surface and survived, we would not see flames. We would see architecture. Currents of plasma, loops of magnetic tension, boiling granules the size of continents rising and falling like breathing skin. Updrafts of heat, downdrafts of cooled plasma, convection as heartbeat. A star is not static. It pulses. The warmth we receive as gentle sunlight began as unimaginable violence. Photons born in the core spent thousands, sometimes millions of years bouncing inward, until finally rising toward the surface, like ideas struggling toward clarity. By the time they reach us, they are old, ancient light, softened by eternity. Heat travels slowly inside stars, quickly across space, and instantly through evolution. At 120 the suns, life on Earth fails, but for a star, this temperature is infancy. It is the threshold where molecules melt but not yet disappear, where substance vibrates fast enough to change but slow enough to remember. At 1,000 degrees C, minerals separate. At 10,000 degrees C, molecules break into atoms. At 1,000 degrees C, structure evaporates, only charge remains. Temperature erases identity to write new ones. The elements of your bones were born in these thermal crucibles. Calcium, forged in red giant hearts. Iron, born in supernova collapse. You are a star's autobiography, cooled into biography. Imagine drifting from a stellar surface outward into night. At first, heat dominates. Planets near the star burn airless. Even metals glow like molten thought. Volatile gases refuse to settle. Oceans cannot exist. Chemicals escape into vacuum like memory, into dream. Warmth is movement. Too much movement means nothing holds. Farther out, a band of balance. Temperate orbits, atmospheric possibility. Water condenses, clouds swirl, surface cools enough to solidify. Rain falls. Rivers carve. Heat and cold collaborate. Continent logic emerges. The habitable zone is not a place. It is a temperature literacy. A planet lives only if it can interpret heat. Reflect some, store some, breathe some. Too little atmosphere, like Mars, and warmth escapes. Too much, like Venus, and heat smothers. Life is the translator between extremes. Even now, Earth balances at the edge, held between starfire and cosmic frost. Day warms, night cools, seasons tilt, oceans absorb, mountains store. The biosphere is a thermal negotiation without end. Temperature isn't weather. It is memory and future colliding. Every sunrise is a reminder of stellar origin. Every winter is a reminder of interstellar heritage. We are the narrow miracle between. Part 2 ends with a truth that becomes our compass. Life is heat slowed and cold awakened. Next, we descend through planets, atmospheres, and the chemistry that thrives only in fluctuation. Cold is not the opposite of heat. It is its archivist. Where fire forgets, frost remembers. At 270 BTC, matter approaches stillness so complete that time itself seems to pause. Not stop, but hover, like a breath held forever. Molecules no longer react, not because they are dead, but because motion, the engine of chemistry, has gone quiet. Cold is suspension, not absence. A grain of interstellar ice drifting far beyond the planets remains chemically intact for billions of years. No rust, no decay, no erosion, only silence. In that silence lies possibility. Methane preserved beside water, ammonia beside carbon chains, complex organic molecules held in sleep so deep they might one day awaken as life. The universe does not destroy its ingredients. It stores them in shadow. Imagine touching a rock that has not warmed once since the birth of stars. A relic colder than memory. A fossil not of creatures, but of chemistry. Hidden inside could be building blocks older than galaxies, structures that could form proteins, lipids, even consciousness, if stirred. But nothing stirs at 270 degrees. Cold is a closed book, Add just a touch of heat, a whisper of +130°C, a breath of +180°C, and those ancient molecules begin to move, to think. They link, twist, fold, test new shapes like dreams forming inside stone. Heat is the editor of the archive. Cold is the library. Life requires both. Even planets reflect this duality. On the night side of Mercury, temperatures plunge low enough to fracture stone. Rocks crack from contraction, shattering like glass too thin for its frame. Thermal stress writes geology. Every sunrise is a sculptor. Cold makes matter rigid, but rigidity breaks. On Europa, Jupiter's moon, surface ice sits at 170°, hard as diamond, unchanging for centuries. But below, warmth churns. Tidal forces knead the moon like slow cosmic dough. Ice above, ocean beneath, a world split by temperature. Where there is contrast, there is motion. Perhaps beneath that frozen shell, hydrothermal vents rise like sunken suns, warming water to 100°C, dissolving minerals, sparking chemistry. Creatures, if they exist, would not fear cold or heat, but breathe through the gap between them. Life is a negotiation, not a climate. Even comets live this cycle. They sleep in darkness for eons, then wake as they approach the sun, releasing tails of vapor, memory turning to movement. Their cores remain frozen, but their skins flare with heat. Half archive, half awakening. Stories with two temperatures. Earth learned this rhythm too. Early oceans were warm enough to react, yet cool enough to remember. Proteins folded without burning, RNA copied without freezing. The first cell was a compromise between fire and ice. We are their inheritance. Your body carries liquid water only because Earth rests in a band where heat cannot boil it and cold cannot lock it away. Every living heartbeat is temperature maintained. 30-70 not by chance but by cosmic arithmetic. Too hot, proteins unwind. Too cold, reaction stops. You are a thermal equation solving itself every second. Part 3 concludes with a quiet truth. Cold is the keeper. Heat is the teacher. Life exists in the page where they meet. Next, we enter the chemistry of survival, adaptation, and the strange ways matter behaves when pushed beyond comfort. Heat is not merely energy, it is persuasion. It pushes atoms apart, loosens bonds, urges molecules to break and remake themselves. Where cold archives, heat edits, rewriting matter as if the universe were drafting and redrafting its own existence. At Pablo 120°C, earthly life begins to fail. Proteins unwind, membranes lose cohesion. But in cosmic terms, this warmth is minor. Barely the first step on the ladder of thermal transformation. Ice melts, water vaporizes, rocks begin to crack. But the real revolution starts far above this threshold, where heat is no longer sensation, but force. In a vacuum, heat behaves differently. Without air to carry it, without molecules to collide, warmth travels only through radiation. A metal panel in sunlight may reach 122 in minutes, while its shadowed side falls to 150 at the same moment. A spacecraft becomes a thermal contradiction, blistering front, frozen back. Expansion and contraction fight for dominance. Screws loosen, circuits warp. Structure breathes, heat grants movement. Cold grants memory. Both demand adaptation. Every planet wears temperature as landscape. On Mercury, daytime heat melts minerals into glass, while nights split the surface like old bone. On Venus, +470°C thickens the air into near liquid pressure, crushing probes in hours. Heat there is not fire, it is weight. Atmosphere so dense it feels like a slow ocean of acid and carbon dioxide. Warmth becomes pressure. Pressure becomes fate. Travel farther outward, and heat becomes rare currency. Mars retains warmth poorly. Its thin air cannot hold the sun. Daylight warms the desert to comfort, but nights plunge into lethal frost. A world that exhales heat, but never inhales enough to keep life constant. Temperature swings like tide, not oceanic but atmospheric. Life may require not temperature, but temperature rhythm. Oceans on Earth store heat like memory. They inhale sunlight and release it slowly, smoothing climate into something survivable. Without water, days would burn and nights would freeze. Without atmosphere, warmth would scatter like dust. The miracle is not heat itself, but retention. Habitability is the art of not letting go. At 120°, the boundaries begin to change. Water boils away in vacuum. Proteins unravel. Yet certain extremophiles survive. Bacteria near Earth's hydrothermal vents, thriving where minerals rise at 100 to 400 degrees. Pressure keeps liquid stable. Chemistry dances. Life bends, does not break. Heat, when moderated, is instruction. At higher temperatures, thousands, tens of thousands of degrees, matter forgets solid and liquid states. Gas becomes plasma. Electrons roam free. Light is born. Stars ignite. Endothermic impossibility becomes exothermic truth. Heat writes structure where cold would keep pages blank. Fire is evolution accelerated. Yet, if heat wins absolutely, systems fail. If cold wins absolutely, systems sleep. Planets exist only because neither extreme rules completely. Continents form because magma cools. Clouds rise because seas warm. Storms turn because poles freeze and equator breathes. Life is circulation, thermal, chemical, temporal. Part 4 closes on a shift in perspective. Temperature is not a condition, it is an algorithm. Next, we move into the machinery of planetary heat, oceans that boil without boiling, and the strange balance that makes consciousness possible. Temperature does not simply shape worlds, it chooses which worlds can think. Between 272 and 120 molecules learn flexibility, chemistry gains vocabulary, and matter can make mistakes. And from mistakes, evolve. Life is not built from perfection. It is built from thermal uncertainty. Consider a pool of early Earth water, fluctuating gently through day and night. Day warms the surface. Molecules move, collide, test new structures. Night cools the mixture. Unstable shapes break apart, but promising ones survive. Memory begins as what heat does not erase, and what cold does not immobilize. Warmth writes the sentence. Cold proofreads it. At minus 120 degrees, most earthly proteins denature, but some organisms redefine the rules. Thermophiles near volcanic vents fold enzymes that remain stable deep into heat. Their membranes tighten, their DNA wins like coiled armor. They do not resist heat, they negotiate with it. Life does not avoid extremes, it adapts within them. Deep beneath the ocean, chimneys of mineral black smoke release water at 400 degrees, but pressure keeps it liquid, dense, electric with ions. Chemistry crackles like storm light. Hydrogen sulfide replaces oxygen. Iron becomes nutrient, not poison. Life grows where temperature seems impossible, not because the heat is kind, but because cold waits nearby to cool it again. Cycle is survival. Imagine now a planet without this rhythm. Permanently hot or permanently cold. No tides of temperature to drive metabolism, no gradients to fuel complexity. A world like Venus remembers nothing. Chemical potential drowns in uniform heat. A world like Pluto remembers everything, but never revises. Life cannot thrive in monotony. A living world is one that never stops changing temperature. Even Earth owes its breath to its imbalance. Rain condenses in cold skies and falls onto warm oceans. Ocean currents carry heat toward ice. Ice carries memory toward tropics. The planet thinks through temperature, distribution as cognition. You feel this in your body? Fever accelerates metabolism, but threatens identity. Hypothermia slows reactions until thought dissolves. The narrow band in between is awareness, consciousness balanced like shoreline between tide and sand. Mind is a thermal phenomenon. Now imagine biology adapted not to one band of temperature, but to many. Creatures of Europa surviving fluid oceans beneath frozen crust. Organisms on Titan swimming through methane lakes cold enough to crack steel. Life floating between states, neither water-based nor carbon-bound as we know it. Alien cells may use heat not to metabolize, but to restructure. Cold not to rest, but to store and retrieve memory. Evolution is temperature learning itself. If we traveled far beyond the sun, into regions where cosmic microwave background hovers near 270 C, spacecraft and body would freeze to silence, unless engineered for oscillation. Not just insulation, but rhythm, heating cycles, phase-shifted fluids, molecular antifreeze. To live in deep space, life must beat like a heart. Warm, cool, warm, cool. Not stable, dynamic. Perhaps consciousness in distant civilizations does not burn like ours, but flickers, waking only when heat from tidal stress raises oceans, sleeping when cold returns to preserve cells. Thought stretched across millennia like a slow star pulse. Life does not require time as we know it, only contrast. Part 5 ends with the compass for all future chapters. Temperature is evolution's language. Life is the sentence written across it. Next, we move to heat unimaginable, fusion-born, plasma-bright. Stars as furnaces of identity and forgetting. Heat has a threshold beyond which identity collapses and matter becomes something else. At a few hundred degrees, water turns to vapor, rocks fracture, metals soften. But climb further, past thousands, tens of thousands of degrees, and molecules cease to exist. Atoms themselves loosen. Electrons drift away. Structure dissolves into charge. This is the territory where heat is no longer temperature. It is transformation. In stellar interiors, plasma churns like liquid lightning. Protons collide with unimaginable force. Fusion is not flame, but pressure and temperature arguing until matter rewrites itself. 4 hydrogens merge into helium, then helium into carbon, carbon into oxygen, neon, silicon. Each step more difficult, each step hotter, each step closer to the limit. Stars are furnaces where heat invents new matter. Iron is where invention stops. At that point, fusion consumes more energy than it releases. The star, like an exhausted mind, cannot think forward anymore. It contracts violently, and if massive enough, explodes. A supernova is heat beyond comprehension. Temperature so high it erases atoms, then scatters them as cosmic confetti for new worlds to gather. We live on the ashes of thermal violence. Every cell in your body contains star temperature ghosts. Calcium forged in red giants, iron born in supernova shockwaves, oxygen shaped in the bellies of dying suns. Heat is ancestry. Cold is memory. You are both. Now imagine drifting away from such a star, not infinitely, just slowly. Warmth fades. Plasma arcs settle. Hydrogen fusion quiets like music at dusk. Particles cool into atoms, atoms cool into molecules. Heat unwinds from chaos into chemistry. Temperature is the bridge between light and form. A planet in this region begins to hold oceans. Minerals bind into continents. Atmosphere condenses to weather. Storms arise because heat is uneven, because cold still whispers from the shadows. Every raindrop is a negotiation between boiling and freezing. Life blooms where heat and cold cannot agree. At 120 degrees, moderate by cosmic scale, biological matter strains to remain itself. Proteins unravel. DNA breaks like silk in fire. Yet extremophiles adapt. They fold enzymes tighter, shield membranes with wax and salt. Life negotiates temperature like a diplomat negotiates peace. Survival is adaptation, not avoidance. Plants cool through evaporation. Animals warm through metabolism. Planets moderate through rotation, ocean flow, atmospheric scattering. Nothing in the universe survives through stasis, only through response. Heat asks, will you change? Cold asks, will you remember? Life answers, I will do both. And so consciousness arises not from warmth or frost alone, but from fluctuation, from the constant rewriting of chemical possibility. Part 6 ends with a truth at the core of existence. Heat creates. Cold sustains. Life pulses between. Next, we descend into extremes. Black holes, frozen voids, neutron stars, where temperature bends reality itself. We tend to imagine heat and cold as sensations, comfort or pain. But the universe feels neither. Temperature to the cosmos is movement, vibration, probability. Matter is a dancer, and heat is tempo. Slow the motion, and a molecule becomes archive. Accelerate it, and the same molecule becomes music. Temperature is rhythm embodied. At 207 degrees, near absolute zero, motion almost ceases. It is not death, it is suspension. Electrons hover in probability shells like thoughts held but not spoken. Change cannot happen. Reaction cannot begin. The universe waits in a silence older than stars. Cold is cosmic patience. But add energy, slowly, and the dance begins. At 150 degrees, simple molecules can shuffle and reorganize. At 50 degrees, complex organics flex like waking limbs. By plus 120 degrees, water flows, membranes soften, proteins fold, and chemistry steps from silence into language. Heat gives nouns verbs. At 120 degrees, biological molecules lose shape, but not identity. A protein uncoils, but the memory of coiling remains. Life at this boundary learns flexibility. Thermophiles near volcanic vents rewrite proteins like origami tolerant to flame. Fire does not destroy them. It teaches them new folding rules. Heat teaches adaptation. Now ascend higher, thousands of degrees, tens of thousands. Atoms break into ions. Electrons fly free like birds startled from a tree. Matter is no longer matter. It is potential. Plasma does not have form. Plasma dreams of form. Stars are the universe dreaming out loud. Their heat does not just burn, it builds. Fusion writes elements into existence. Carbon for life, oxygen for oceans, iron for blood and planet cores. Without stellar heat, there is no chemistry complex enough to remember itself. Our bones are the cooled memory of stellar furnaces. But the story bends when heat and cold meet. When neither wins. A planet with oceans breathes because sunlight warms the surface, while deep water holds ancient cold. Evaporation writes clouds, condensation writes rain. Heat rises, cold falls, cycle becomes heartbeat. Life is circulation, not temperature. Imagine an organism built not for one climate, but for contrast. Cells that freeze to conserve energy, then thaw when heat returns. Metabolism that flickers like day and night. Thought stretched over centuries like a slow neural tide. On distant moons, this may not be imagination, but biology. Europa's ocean, warmed by tidal friction beneath an ice shell, might host creatures that sleep during cold cycles, then awaken when hydrothermal warmth rises. Life built not on constancy, but on oscillation. Adaptation as pulse. Temperature extremes create behaviors impossible in gentle climates. Fungi that survive in 50 degrees Antarctic rocks. bacteria that endure 120 degrees inside deep ocean vents. Life finds gaps, thrives in margins, evolves in gradients. We are not exceptions. We are results of this pattern. Your body is a thermal compromise. Warm blood, cool skin, a core that must not boil, and a brain that must not freeze. You live because you balance. You think because you fluctuate. Consciousness is thermal equilibrium in motion. Part 7 closes on the realization we carry forward. We are heat slowed enough to remember, and cold warmed enough to move. Next, we enter the impossible places, where temperature bends space-time and reality itself trembles. Most of the universe never feels warmth. More than 99% of cosmic space rests near 270 degrees, a temperature so low that motion nearly collapses into stillness. And yet, this cold is not dead. It is storage. It is preparation. It is a library of atoms waiting for a reason to move again. Cold is potential with infinite patience. Stars burn, planets age, civilizations appear and vanish, while the deep cold remains, preserving the raw ingredients of everything that was and could be. Hydrogen sleeps like ancient snow. Carbon drifts as dust, unchanged for eons. Amino acids freeze inside comets like seeds locked in crystal time. Cold cannot create life, but without it, life would have nothing to build from. Now travel inward, toward heat. Past planets dusted with frost, past the silent drift of interstellar clouds, into the electric breath of a star. Temperature rises not by degrees, but by identity. Water no longer behaves like water. Rock no longer behaves like rock. Heat here is not warmth, it is meaning. At thousands of degrees, atoms shed electrons. Molecules dissolve into chaos. Chaos becomes structure again, fusion, plasma, light. Heat is not disorder. Heat is reorganization. Even black holes obey temperature, though their meaning of it is warped beyond intuition. A black hole is not cold, it only appears silent. Hawking radiation whispers that its temperature exists, faint but real. The more massive the hole, the colder it is. A stellar mass black hole may be nanokelvins from absolute zero, a smoothness so deep it hides fire beneath. Black holes are furnaces disguised as zero. Get close, not physically, but conceptually, and temperature begins to stretch reality. Spaghettification, acceleration, tidal forces, heat and gravity blur into one script. Matter falling inward compresses, heats, ionizes, unwrites itself. What was once atom becomes information, encoded on the event horizon like frost storing history. Cold preserves matter. Black holes preserve information. Beyond stars lie stranger furnaces, neutron stars, where a teaspoon weighs 1 billion tons. Here, heat is gravity wearing a mask. Temperature so high that atoms collapse into neutrons, so cold that quantum rules harden like steel. Superfluid cores swirl without friction, a paradox. Both ultra-hot and perfectly still. Temperature bends space-time when matter becomes too dense to remain ordinary. Now return to planetary scale. Not down, but sideways. Moons like Io erupt with sulfur fire, while Europa hides oceans under ice. Titan holds methane lakes cold enough to crack steel, yet gentle enough for chemistry to dream. These are not dead worlds. They are laboratories for temperature's imagination. Cold worlds think slowly. Hot worlds think violently. Earth thinks in rhythm, warmed by day, cooled by night, stirred by seasons. If either extreme won fully, thought would end. No room for memory in constant fire, no room for change in eternal frost, but between the two, movement, metabolism, consciousness. We are not alive despite temperature. We are alive because of its imbalance. Even your blood carries two truths: warmth to flow, coolness to preserve structure. Your body is a negotiation. Proteins folding and unfolding, water evaporating and condensing, heat rising from your core while skin releases it to air. Your life is a thermal conversation happening 37 degrees Celsius at a time. Part 8 closes with the realization that will guide the next descent. Cold stores the universe. Heat awakens it. Together, they write time. Next, we travel to the edge of extremes, where heat becomes space-time curvature and cold becomes nearly perfect zero. Temperature does not merely shape matter, it shapes time. Heat accelerates reaction, pushes atoms to collide, forces molecules to change. Cold slows everything until reaction becomes memory. If heat is movement, cold is duration. Time itself is thermal. A universe filled only with cold would last forever, but never evolve. Frozen chemistry cannot rewrite itself, cannot attempt new shapes, cannot fail or succeed. And without failure or success, there is no life, only preservation. A universe of only heat would burn fast and bright, but briefly. Molecules would snap apart before they could organize. Matter would exist only as plasma, brilliant but unstable, like a thought that never becomes language. Life exists because the universe is neither entirely patient nor entirely impulsive. Consider space between galaxies. Temperature hovers just above absolute zero. 270 degrees Celsius, a silence deep enough to suspend time. Gas clouds there drift unchanged for millions of years, waiting for gravity to compress them into stars. They do not evolve, they anticipate. Then imagine the core of a young star. 10 million degrees. Time there bursts like lightning. Fusion races forward. Matter transforms in seconds. A star lives its entire chemical life inside its furnace before even a fraction of that energy escapes to space. Cosmic time has two hearts, one frozen, one burning. Between them is the rhythm we call existence. When a massive star collapses into a neutron star, temperature and gravity fuse into one law. Matter becomes so dense that electrons merge into protons, forming neutrons. Heat inside exceeds billions of degrees, yet the surface radiates cold compared to its core. A neutron star is fire wrapped in ice. Tidal forces tear atoms into quarks, crusts crack like porcelain, magnetic fields twist space like cloth. Temperature here is paradox, a knife sharp on both sides, too hot to comprehend, too cold to escape. Cold compresses time, heat accelerates it. Neutron stars do both. No organism we know could survive such extremes. But life elsewhere may not resemble us. Perhaps consciousness could flicker in magnetic storms, or chemistry could exist inside crystalline lattices cooled near zero. Life could be thermal fluctuation itself, not cells, but oscillations. Life may not need form, only rhythm. Now look inward again. Earth. Warm seas, cold poles, winds that trade heat like currency. Storms exist because temperature disagrees with itself. Mountains create shadows where cold pools. Deserts shimmer where heat dominates. Rain is negotiation. Snow is memory. Rivers are thermal translation from high to low. A planet thinks through temperature. Even a forest is a thermal system. Leaves cool through evaporation. Roots store winter's cold. Animals regulate heat through blood. Migration is movement along comfort gradients. Hibernation is biological time slowed into cold. Life is heat slowed into thought. Cold slowed into sleep. And human civilization itself, industry, technology, culture, exists because we learned to move heat. Fire, engines, electricity, all are controlled temperature gradients. A computer is nothing but electrons guided by thermal balance. A city is metabolism scaled up. We are architects of temperature, even as it created us first. Part 9 concludes with a truth that opens the next threshold. Cold makes time. Heat makes change. Life is the thread between. Next, we travel into the deepest extremes of both ends. Nearly absolute zero and matter hot enough to break space-time. At the extremes of temperature, reality bends. Heat becomes force, cold becomes silence, and matter is forced to choose, transform or sleep. But beyond the edges of familiar physics, temperature does more than change states. It reshapes the laws themselves. Near absolute zero, atoms behave like citizens of a different universe. Motion nearly stops. Resistance vanishes. Electrons move through metals without losing energy. Superconductivity is not magic. It is order achieved through stillness. Cold brings perfection, where heat brings creativity. Stillness is not death. It is clarity. In Bose-Einstein condensates, created at billionths of a degree above absolute zero, many atoms act as one, a single quantum wave, unified thought. Identity dissolves into harmony. This is what cold can do when pushed to its perfect form. It makes matter singular. Heat, pushed equally far, does the opposite. At 1 billion degrees, no atom can hold together. Quarks break free from protons. Matter becomes liquid light, quark-gluon plasma, the same state the universe held microseconds after the Big Bang. Cold unites, heat unravels. Both reveal truth. The infant universe was heat, pure expansion, pure motion, no molecules, no stars, no time as we understand it. Just temperature so high that matter had not yet chosen structure. As the cosmos cooled, choices formed. Quarks found partners, atoms were born. Later, stars. Later, planets. Later still, us. Creation was not a bang. It was cooling. The opposite future waits far ahead. Stars burn out one by one. Fusion ceases. Light fades. Galaxies drift apart like silent continents. With time, everything moves toward equilibrium. Energy spread too thin to drive change. Temperature flattening into final sameness. Heat ends quickly. Cold ends slowly. And yet life is neither flame nor frost. It is imbalance held in motion. Earth remains alive because it refuses stability. Warm oceans meet cold polar caps. Wind carries energy from equator to pole. Weather is the argument that produces existence. Remove contrast, and the mind goes dark. A world without variability would have no seasons, no storms, no evolution. Every creature alive today is a child of thermal tension. Tropics competing with glaciers, volcanoes lifting continents, ice ages sculpting memory. Even our brains operate as cycles: sleep, wake, heat of thought, cool of recovery. Consciousness is a thermal wave. At 120°C, life strains but adapts. At 270°C, life sleeps but endures. But at the extremes, quark plasma, Bose-Einstein unity, life as we know it cannot exist at all. But perhaps life as we know it is only one interpretation of temperature. Imagine minds that form only at quantum stillness, thinking slowly across centuries. Imagine organisms made of plasma filaments inside stars, born of heat instead of flesh. Imagine consciousness that pulses, dormant in frost, awakening in fire. Temperature is not limit, it is spectrum. We occupy only a thin band, comfortable, breathable, fragile. Above us lies creation through chaos. Below us lies clarity through stillness. We are the bridge between invention and memory. Part 10 ends with the doorway to the final descent. Heat creates universes. Cold preserves them. Life exists only as long as both continue. Between flame and frost, there is a threshold where matter hesitates. A boundary not defined by numbers, but by behavior. At moderate temperatures, molecules move but do not scatter, bind but do not freeze, break but rebuild. This band of uncertainty is where chemistry becomes story. Life is born not from extremes, but from hesitation. Consider a drop of liquid water, not ice, not vapor, but the fragile state in between. Ice preserves structure perfectly, but does not evolve. Steam carries motion, but not memory. Water is compromise, and compromise is creativity. It bends without breaking, shapes without shattering, dissolves minerals, transports nutrients, wraps molecules in flexible cages. Life chose water because water chose balance. At 270 degrees, water becomes glass, flawless, eternal, unmoving. At 120 degrees, water becomes sky, structure lost, energy liberated. In between, it becomes ocean, cell, thought. Temperature turned element into environment. A molecule is not alive, but it can learn. Heat gives molecules direction, cold gives them discipline. Proteins fold only because they are warm enough to move and cool enough to hold shape. DNA stores memory because its bonds vibrate only slightly, not too fast to break, not too slow to erase. Even the double helix is a thermal agreement. Life is a treaty between motion and restraint. Human thought, too, is thermal. Neurons fire because chemical gradients flow, energy moving from high to low like storm fronts across the brain. A thought is temperature rearranging itself. Memories form in proteins and synapses that flex, warm enough to change, cold enough to last. A brain is 37 factors of negotiation. If it cools, signals slow. Consciousness dims like dusk over water. If it overheats, proteins unfurl, cells convulse. There is no thought at 0 degrees, no identity at 60 degrees. Intelligence is a thermal corridor just wide enough for meaning. We are temperature thinking itself. Move outward again. Planetary scale. Earth breathes because it rotates between day and night. Warmth rises. Cold settles. Wind becomes weather. Tides become calendar. Without seasons, there is no migration, no evolution, no challenge to overcome. Without climate variation, intelligence does not sharpen. It stagnates. Mind is sharpened by winter and renewed by spring. Even civilizations are thermal structures. Fire shaped the first tools. Cooking unlocked calories for brain expansion. Engines turned heat into movement. Computers steer electrons balanced between conduction and resistance, thermal control at microscopic scale. The internet itself is a network of cooled servers translating heat into thought. Humanity is temperature-made infrastructure, and yet we exist precariously. If Earth warms too far, oceans rise, storms intensify, ecosystems tilt toward chaos. If Earth cools too long, glaciers advance, biomes collapse, memory shrinks to frost. Civilization, like a cell or a star, lives only in contrast, never in constant. Survival is balance held against drift. One day, when stars fade and cosmic background falls closer to absolute zero, heat will weaken. Change will slow, evolution will dim. But life, if it endures, may adapt. Thought may stretch across centuries instead of seconds. Minds may become winter, slow but unending. Cold writes endurance where heat writes action. Perhaps intelligence will one day freeze into clarity, waking only when tides of geothermal warmth rise through alien oceans, or when gravity squeezes heat from shifting moons. Life may pulse like a heartbeat stretched across millennia. No thought is lost, only slowed. Part 11 closes with the truth we cannot escape. We are warmth refusing chaos and cold refusing silence. Next, we approach the final descent, where temperature becomes memory and life is the luminous border between two infinities. As we approach the edge of extremes, temperature begins to define reality itself. Not just how matter behaves, but what matter can be. Heat unlocks chaos. Cold preserves possibility. Between them lies everything that remembers, evolves, or dreams. Now imagine absolute cold. Not just low temperature, but zero motion. No vibration, no change. In that stillness, quantum particles lose individuality. Wave functions overlap, identity softens. Bose-Einstein condensates prove it. Many atoms become one body, one mind, one continuous field. Cold erases separation. Heat does the opposite. Push temperature high enough and matter loses cohesion. Protons split, quarks run free. In quark-gluon plasma, individuality is everywhere. No structure, no bonds, only motion. This is the universe before time had shape. Heat erases unity. We exist because the universe cooled from chaos, but not enough to stop moving. Atoms formed, but did not freeze. Molecules danced, but did not fly apart. Life is equilibrium, stretched across cosmic tension, pulled between order and entropy. Survival is the art of holding shape while still changing. Consider frost on a window, delicate, branching like lungs across glass. It forms because molecules slow, align, remember geometry. Ice is memory made visible. Now heat the glass. Frost retreats into liquid. Disorder returns, movement reawakens. Both states contain information, one static, one dynamic. The universe dreams in two dialects, ice and fire. Zoom out to galaxies. Stars heat space. Dark matter cools expansion. Gravity collects, temperature decides. Where gas is warm, stars do not form. Where gas cools, clouds collapse into fusion and light. Galaxies are thermal negotiations on scales too vast for comprehension. We are made of starlight only because hydrogen once became cold. Cold gathered atoms. Heat ignited fusion. Planets formed from the aftermath. Dust warmed just enough to merge, cooled just enough to solidify. Meteorites delivered organics, preserved by cosmic frost for billions of years. Life is the child of cooling starlight. If temperature had dropped too fast, molecules would have frozen incomplete. If temperature had stayed too hot, molecules would have shredded apart. Only the middle path allowed complexity to climb from chemistry to consciousness. You are balance, written in biology. Inside every cell, temperature fluctuates like breath. Enzymes accelerate near warmth. DNA unwinds to replicate, then cools to fold safely once more. Even the brain is oscillation, electrical storms followed by silence. Wake and sleep, heat and rest. Thought is a thermal tide inside bone. Now look forward, far beyond us. Stars will fade, fusion will slow, galaxies will cool into dim embers. But black holes will remain, cold externally, hot internally, paradox embodied. Hawking radiation whispers heat into eternity. The universe may end not in fire, but in memory. Cold will preserve what remains, particles drifting like quiet pages of a library. Heat will flicker in final black hole evaporation. Eventually, temperature may flatten, and motion may slow into stillness. Yet even then, possibility remains. Quantum fluctuations, virtual particles, perhaps a new universe, born from thermal imbalance as this one was. Creation may be a cycle of cooling and ignition without beginning or end. Temperature writes eternity in slow paragraphs. Part 12 ends with the truth beneath all existence. We are not separate from heat or cold. We are made of their conflict. Next, we descend to the final chapters. Death of stars, birth of life, and temperature as the script of the cosmos. Stars die in temperature, not metaphorically, literally. Their lives are the arc of heat, learning failure, and frost learning patience. A star begins in cold, collapses into fire, burns through youth, dims into age, and ends in one of two fates: explosion or silence. Heat is birth. Cold is legacy. A small star cools with dignity. It swells into a red giant, breathes away its outer layers, and leaves behind a white dwarf. Hot at first, then cooling for trillions of years. It becomes a crystal sphere of oxygen and carbon, a cooled diamond in the dark. No fusion, no flame, only memory. A white dwarf is a star's autobiography written in temperature. But a massive star will not fade quietly. Its heat outruns itself. Fusion climbs elements like rungs on a ladder, until iron ends the climb. Then, collapse. Gravity outpaces temperature. The star folds inward like a thought swallowed too fast. In less than a heartbeat, matter compresses beyond recognition, and heat erupts outward as supernova. Heat dies violently, but it does not die in vain. Supernova light forges heavier atoms: gold, uranium, iodine, copper, phosphorus. Everything needed for oceans, for blood, for neurons. These ashes become planets. These planets become ecosystems. These ecosystems become stories. We are stardust cooled enough to speak. Now consider planets themselves. A world begins hot, molten, chaotic. But cooling writes continents, oceans, atmosphere. Too much heat and no crust forms. Too little heat and oceans freeze to granite. The narrow corridor between is where landscapes dream. Earth is not a place, it is a temperature phenomenon. Volcanoes rise where heat escapes. Ice caps form where cold collects. Rivers flow from thermal imbalance. Storms circulate energy. Climate negotiates equilibrium. Life emerges from that tension, not from stability. Existence is kinetic compromise. Even ecosystems are thermal maps. Tropics store heat. Poles store memory. Seasons trade one for the other. Rainforests pulse like warm hearts. Tundras slow like ancient minds. Coral reefs glow in equatorial light. Glaciers archive centuries of atmosphere. Biodiversity is temperature playing chords instead of single notes. Life is harmony of contrast. Now look to the microscopic. Cells navigating heat as carefully as planets do. Mitochondria burn glucose into warmth. Enzymes accelerate with degrees. Membranes soften or stiffen with climate. The body is a symphony of controlled combustion restrained by cooling architecture. You are a regulated fire. But minds are even stranger. Thought blooms only in a narrow thermal corridor. Too cold and synapses slow. Too hot and proteins unravel. Consciousness requires instability, enough to change, but not enough to collapse. Awareness is chaos tamed. And yet, the universe may know awareness on scales far beyond organic thought. Neutron stars, black holes, quantum condensates. These may hold forms of order or computation alien to biology. Temperature might think, remember, or dream without neurons at all. Life may be only one dialect of heat and cold. Perhaps memory could exist as superconducting circuits near absolute zero, thinking slower than glaciers, but longer than galaxies. Perhaps intelligence could exist inside plasma filaments of stars, thought shaped by magnetic fields, memory encoded in radiation. Perhaps consciousness is not an exception, but a temperature effect waiting to recur. The universe may think in ways we cannot. And what of endings? Not just death of stars, but death of temperature. When the universe expands so far that heat spreads thin, motion slows, fusion ends, chemistry quiets, everything cools toward night. But even then, black holes radiate, photons drift, particles jitter. Zero is an approach, never a destination. Cold writes forever. Heat may return through vacuum fluctuations, quantum tides, or new expansion. Another universe could ignite where this one cools. Creation is thermal recurrence. Part 13 closes with the truth at the center of every atom, star, and mind. We exist because heat remembers possibility, and cold remembers everything else. Next, the final movement. A closing reflection on life as the luminous median between two infinities. Temperature is not a measurement. It is a boundary between what can exist and what must transform. As we near the final descent, the question becomes not what heat and cold do to matter, but what they do to meaning. Everything that lives, remembers, or thinks stands suspended between two absolute destinies: the silence of perfect cold and the brilliance of unstoppable heat. Life is what temperature refuses to simplify. Imagine a universe without cold, only fire, plasma, motion. No molecules stable enough to bond, no chemistry to evolve, no memory to hold shape. Creation would burn itself into instant extinction. Now imagine a universe without heat, only frozen atoms, still, perfect, eternal. No reaction, no movement, time without event. A book written cover to cover in blank pages. We live because the universe stands between these two books and writes a third. Planets cool just enough to solidify. Stars burn just long enough to assemble the elements of life. Oceans warm enough to flow, cool enough to condense. Cells survive only because their inner heat dances a fraction below destruction and a fraction above sleep. The universe is a knife edge, and life is the balancing foot. Survival is equilibrium in motion. But temperature is not gentle. It breaks as much as it builds. A planet too close to its star becomes desert, atmosphere stripped, oceans boiled, memory erased. A planet too far becomes glacier. Frozen oceans, locked clouds, progress held like a thought unspoken. Habitability is not geography. It is thermal literacy. Worlds that thrive are worlds that negotiate energy. Earth negotiates constantly. Volcanic heat rushes upward. Polar cold pushes downward. Jet streams, monsoons, ocean currents redistribute warmth like blood through a body. Climate is not a state. It is circulation. And circulation is what keeps a planet awake. Temperatures write behavior. A rainforest believes in abundance. It stores no heat because it trusts tomorrow. A desert trusts nothing. It hoards every degree like currency. Tundra conserves. Tropic releases. Temperate lands oscillate like lungs. The planet breathes temperature the way lungs breathe air. Zoom inward, the scale of organisms. A reptile is a poem of sunlight, its metabolism depending on morning warmth. A mammal burns internally, defying cold with chemical fire. A seed sleeps through winter and resurrects in spring. An organism timed by thermal clocks. Life reads temperature as language. Even human emotion carries thermal grammar. Anger heats the body, grief chills it. Warm hands comfort, cold silence distances. We say passion burns and memory freezes because temperature describes the architecture of experience itself. We feel with fire and remember with frost. Neural activity depends on degrees precise to decimal. Too cold, synapses slow, thought dissolves. Too hot, proteins unfold, identity disintegrates. Consciousness exists in a corridor only a few degrees wide. Mind is temperature held like flame cupped in hands. Civilization expands because we learn to move heat. Fire allowed cooking, metallurgy, protection. Engines turned combustion into travel. Electricity turned heat into information. Now servers hum in climate-controlled rooms, machines thinking through thermal balance. Information itself is temperature arranged into logic. And still, extremes define us. Heat waves reshape families, migrations, economies. Ice ages sculpt continents and memory. The great die-offs of history were thermal notes: too much fire, too much frost, never static. Change forces evolution. Stability ends stories. The future will be a question of temperature, as the past always was. When stars fade, cold will stretch thought across centuries. When new universes ignite, heat will write new chemistry. Creation and forgetting will continue as heartbeat. Fire forward, frost backward. Part 14 arrives at the final threshold. We exist because we burn slowly enough to remember, and cool slowly enough to continue. Next, the final chapter. A closing reflection on life as the luminous tension between two eternities. We stand now at the final gradient, where temperature becomes not science, but meaning. Where heat and cold are no longer numbers, but metaphors for existence itself. There are two infinities in the universe, one blazing with motion, one silent with memory. Life is what glows between them. We are warmth slowed into awareness. We are cold softened into continuity. When we imagine the cosmos, we picture stars, fire against the void. But stars are only one half of truth. They burn because something colder surrounds them. Heat expands into darkness. Light requires shadow. Without cold, stars would blind themselves and vanish. Without heat, the universe would never wake. Temperature is tension, the most creative force we know. You were born from that tension, not in a poetic sense, literally. Your atoms came from supernova fire. Your water came from ancient ice. Your body is a compromise. Your mind is an equilibrium. You exist because the universe refuses to choose one absolute state. We are not accidents. We are balance. Look at Earth one more time. Oceans breathing evaporation and rain. Mountains channeling warmth upward, glaciers pulling it down. Tropical forests shimmer with thermal abundance, while polar deserts preserve memory in frost. Every climate is a sentence, every season a comma, every evolution a new paragraph. Temperature wrote the story we call life, and that story is still being written. One day our world will cool too much or heat too far. Continents will break or freeze. Oceans will rise or solidify. Humanity will adapt, migrate, transform, or pass into silence like stars before us. But the universe will not end in that moment. It will continue to write, long after we are footnotes. Cold will store what we were. Heat will make something new. Perhaps future life will think slowly beneath ice shells, dreaming across millennia like glacial minds. Perhaps new beings will be born from plasma inside magnetars, built of heat instead of water. Perhaps intelligence will exist as superconducting quantum thoughts near absolute zero, or as radiant structures inside suns. Life is not fragile. It is adaptable to temperature itself. And what of the far future? When galaxies fade, when even black holes evaporate, when the cosmic background cools to a whisper above absolute zero, motion will slow, but never stop. Particles will jitter. Quantum fields will fluctuate. Temperature will breathe, even then. Stillness is not silence. It is preparation. Eventually, imbalance will return, a fluctuation, a surge, a spark. Perhaps another universe will ignite from frozen potential. Perhaps fire will rise again from cold eternity. Creation is thermal cycle. Heat writes beginnings. Cold keeps endings alive. Between those two infinities, consciousness happens, briefly, brilliantly, beautifully. We are here only for a moment, but in that moment, we glow. Remember this as you listen to the quiet of the cosmos. You are the warmth that the universe uses to think, and the coolness it uses to remember. Not star, not ice, but the luminous line between. This is the final truth of temperature. Life is the flame that does not burn, and the frost that does not sleep.